Hey guys, it's Thursday, May 21st. We are going to do 10.5 today, 10.5 notes and examples. We're going to do some examples that aren't on the notes. We have two more sections until the end of the year, 10.6 and 10.7. We are gearing up for Chapter 10 quiz, which is on the 28th. Next week, we're going to just review in preparation for that quiz and take the quiz on the 28th. And then the test will be coming in the first week of June. So here's our warm-up. Pause the video, give it a shot, and then come back and we'll review. So here we go. It says you randomly choose one marble from a bag containing 5 blue, 2 red, 2 green, and 1 purple. Find the probability of each event. The first thing we need to know is how many marbles are in the bag. Well, there are 5 blue, 2 red, 2 green, and 1 purple. There are 10 marbles in the bag, right? 5, 6, 7, 8, 9, 10 marbles in the bag. The probability of choosing a blue marble, there are 5 blue marbles in the bag of 10 marbles. And we could reduce that to 1/2. Half the bag is blue marbles. Number 2, choosing a red marble. There are 2 red, there are 10 in the bag, and I can reduce that to 1/5. Choosing green. The probability of choosing green, there are 2 green, there are 10 in the bag, and I can reduce that to 1/5. Choosing purple. There's 1 purple, and there's 10 in the bag, 1/10. What about not choosing blue? Well, how many marbles are not blue? If 5 of them are blue, the other 5 are not blue. Still 10 in the bag. That's 1/2. What about not red? Well, 2 of them are red. That means that 8 of them are not red, and there are still 10 in the bag. And I can reduce that to 2, I can reduce that to 4/5, right? 2 goes into both of those, 4/5. So this is finding a probability of a singular event. You need to be able to do this. It's the first third of the quiz. Here's the essential question for 10.5. What is the difference between dependent and independent events? Pause the video, write down your essential question. I want to talk about these words, dependent and independent. Independent means that events don't have anything to do with each other, like flipping a coin and rolling a number cube. The outcomes of flipping a number cube have nothing to do with flipping the coin. They're independent of each other. They don't affect each other. Whereas dependent means that they do affect each other. Like if I were to hold a bag of marbles and draw one out and leave it out and then draw again because there are less marbles in the bag. We're going to practice with these two events today, dependent and independent events. Here's our first key idea. The finding probability of 2 or more events, the formula is still the same. We're going to find the probability of each event and multiply them together to find their combined probability. Let's try an example. It says, the first one says, you spin the spinner and flip a coin. What's the probability of spinning a prime number and flipping a tails? So the spinner and the coin, these are independent events because they have nothing to do with each other. What I spin on the spinner does not impact what I flip on the coin. These events are independent. So we're going to do what we've been doing. We're going to find the probability of spinning a prime number, find the probability of spinning a tails, and multiply them. So first we need to figure out which ones are prime. 1 is not prime. It's neither prime nor composite. 2, 3, and 5 are prime. 3 of the numbers are prime. There are 5 of them on the spinner. So the probability of spinning a prime is 3 out of 5. There are 2 sides to this coin. One of them is tails. The probability of flipping a tails is 1 out of 2. To find their combined probability, we'll multiply. 3/10. 3 over 10. Let's see if we can identify which kinds of events are independent or dependent. Let's talk about these. You roll a number cube twice. The first roll is a 3, and the second roll is an odd number. Are the events independent or dependent? So if I roll a number cube, I get a 3. And when I roll the second cube, is 3 no longer an option, or is it still there? It's still there, right? There's nothing that impacts the second roll from the first roll. These events are independent. Independent. You flip a coin twice. The first flip is heads and the second flip is tails. The first flip being heads does not impact the flip being tails. These events are independent. Let's look at the other case here. It says you randomly draw a marble from a bag containing 3 red and 5 blue. You keep the marble and then draw a second marble. So there were 8 marbles in the bag, 3 red and 5 blue. You drew one out and kept it. You put it in your pocket. There are only 7 marbles left in the bag now, and that affects the probability of drawing the second marble. This is an example of dependent events. Because you kept the marble, you changed the outcome. Look at the last one. You randomly draw a marble containing 6 red and 2 blues. You put the marble back. These events are independent, since you put the marble back. But if you had kept it, you would have changed the possible pool of marbles. Let's try an example of dependent events. Here's an example where the events are dependent. People are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first, and then one of your friends is chosen second? So these are 2 events, and they each have different probabilities. So, what's the probability that one of your relatives is chosen first? 5 of the audience members are relatives. There are 100 people in the audience. Now, if your relative gets chosen, right, the probability of your relative being chosen is 5 out of 100. If they are chosen, how many people will be left in the audience? There are 99 people left in the audience now, because your relative was chosen. How many of them are friends? 6 of them are friends. These events are dependent because the relative was chosen out of the audience. It made the audience smaller. To find the probability of them combined, we're going to multiply. Straight across. Whoops, 9,900. Chop off that 0 and reduce 1 over 330. So there's a 1 out of 330 chance that your relative will be chosen first and your friend will be chosen second. You think you have some good chances? This is going to take some practice. Practice on the homework tonight. Come to office hours. Ask me as many questions as you want. This is one of the tougher sections. Get the help that you need. Do the practice that you need to do. Summarize the notes, and I will see you next week. Bye!